So today we are discussing the distance formula that is part of coordinate geometry. So the first case that we are going to consider is if the 2 points are lying on the x-axis, then what would be the distance between them? So let us assume that points A and B are lying on the x-axis. So whenever the points are lying on the x-axis, always remember their y-coordinate is 0. So let's assume the coordinates of points A and B are. So coordinates of points A and B are, A will be x1 and its y-coordinate will be 0. And the coordinates of point B will be x2 and its y-coordinate will be 0. So in this case, distance between A and B will be, okay, so distance between A and B, which can be simply written as AB will be equal to x2 minus x1, where x2 is greater than x1. Okay, so for example, if we have points A, where point A is minus 2, 0, and point B is 5, 0. So as the y coordinates of both the points A and B is 0, the points are lying on the x-axis. Hence, the distance between the 2 points will be the difference between their x coordinates. So here in this case, distance AB will be 5 minus x coordinate of point A is minus 2. So it will be minus 2. So AB will be equal to, so 5 minus of minus 2 becomes plus 2. So it is AB is 7 units. So the distance between the 2 points A and B, which are lying on the x-axis, is equal to 7 units. Now the next scenario is if the 2 points are lying on the y-axis. So if the 2 points are lying on the y-axis. Okay, so if the 2 points are lying on the y-axis, so let's consider the example that points C and D are lying on the y-axis. Okay, so their coordinates will be, always remember, whenever the points are lying on the y-axis, their x coordinate is always equal to 0. Whenever any point is lying on the y-axis, their x coordinate is always 0. So let's assume that the coordinates of points C and D as both are lying on the y-axis, hence x coordinate is 0. Let the y coordinate of point C be y1 and coordinates of D will be 0, y2. Okay, so here distance between C and D will be, so distance between C and D, which can be denoted as CD, will be equal to difference between their y coordinates. Difference between their y coordinates. So it will be y2 minus y1, where y2 is greater than y1. Okay, so let's consider an example. So let's assume that point C is having coordinates. Point C is having coordinates 0, 7, and point D has coordinates. So point D has coordinates 0, minus 4. Okay, so between C and D, whose y coordinate is greater? So y coordinate of C is 7, which is greater than minus 4. Therefore, distance CD will be 7 minus of minus 4, which will be CD will be 7 plus 4, that is CD is equal to 11. And always it is the units. So distance between the points C and D that are lying on the y-axis is 11 units. So these are the two cases in which both the points are lying either on the x-axis or y-axis. And how do we find the distance between the respective points? With this, we proceed further to the next case, and the next case is if the line segment joining the 2 points is parallel to the x-axis. Okay. If the line segment joining the 2 points is parallel to the x-axis. So how do we get to know that the given line segment is parallel to x-axis? How do we get to know that? So in this case, always remember that if there are 2 points whose y coordinates are same, then the line segment joining the 2 points will be parallel to x-axis. Okay, so here let's assume that we have point A whose coordinates are, let's say, x1 and y, and we will have point B whose coordinates are x2 and y. So here y indicates that the y coordinate of both the points A and B is same, and hence the line segment joining the 2 points is parallel to the x-axis. Therefore, in such cases, the length of the line segment AB is the difference between the x coordinates of 2 points. Length of the line segment joining the points AB is equal to difference between their x coordinates. So distance AB, which is denoted by only AB, is equal to x2 minus x1, where x2 is greater than x1. Okay, so here why do we say that AB is parallel to x-axis? Because their y coordinates are same. Okay, now we'll consider an example. Let's consider point A whose coordinates are -2, 3, and point B whose coordinates are, let's say, 9, 3. So what do we observe here? Y coordinate of both the points A and B is same, that is 3, 3. So hence the line segment joining points AB is parallel to the x-axis. Therefore, distance between AB is difference between their x coordinates. Bigger x coordinate minus smaller x coordinate. So 9 minus of -2. So we will have AB is equal to 9 plus 2. That is AB is equal to 11 units. So we have distance between the 2 points AB is equal to 11 units. And why did we find the difference between their x coordinates? Because the line segment joining the points AB is parallel to the x-axis. Now we come to the next part or next case, where if the line segment joining the 2 points is parallel to the y-axis. And how do we get to know if the line segment is parallel to the y-axis? If the x coordinate of the points is same, then the line segment joining them is parallel to the y-axis. So we'll assume the points as C and D. So let's say C is, the coordinates of point C are x, y1, and D is x, y2. So x coordinate of both the points C and D is same, which is equal to x. So in such cases, distance between points C and D is, which is denoted by simply CD, is difference between their y coordinates, which is y2 minus y1, where y2 is greater than, y2 is greater than y1. Now let us consider an explicit example. So let's consider point C, whose coordinates are, let's say, 2, minus 5, and we have point D, whose coordinates are 2, 6. Okay, so as we observe that x coordinate of both the points C and D is same, the line segment joining the 2 points is parallel to the y-axis. Therefore, distance between point C and D, which is denoted by CD, is nothing but the difference between their y coordinates, which is 6 minus 5. So we get CD is equal to 6 plus 5, that is CD is equal to 11 units. Thus, we have considered 4 cases in which we can find the distance between any 2 points, but the 2 points are in such a way that either they are lying on the coordinate axis, or the line segment joining those 2 points is parallel to either of the coordinate axes. Now, there can be cases where the line segment joining the 2 points may not be parallel to either of the axes, or those points may not be lying on either of the axes. So in such cases, we have a formula called as a distance formula, which needs to be used. So here we say that to find distance between any 2 points. So to find distance between any 2 points. Okay, so the formula is, so let's say the 2 points are, any 2 points are point A, whose coordinates are x1, y1, and point B is x2, y2. So the distance between points A and B is given as, so distance between points A and B is given as AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So distance between any 2 points can be calculated using this distance formula, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So how does it look like? It looks like this. So how does it look like? It looks like this, the way it is given here. Okay, so if we copy this formula, so this is the distance between 2 points P and Q, which is like this, which looks like this. Okay, so square root of x2 minus x1 square plus y2 minus y1 square gives us the distance between any 2 points. So let us consider an example. So let us consider an example where, so here they have considered the points P and Q. We'll consider an example where we've been provided with the coordinates of points P and Q. So point P is, let's say, 2, 5, and Q is 4, 7. Okay, now we have to find the distance between PQ. So to avoid any kinds of mistakes, I advise that point P, you should write it like this, point P its coordinates are written as x1 is equal to 2 and y1 is equal to 5. And point Q is given as x2 is equal to 4 and y2 is equal to 7. Now using the distance formula. So to get the distance, we have, whenever you are using any formula, you should write the original formula as it is. Before actually substituting the values, you should write the formula as it is, and then only in the next step you should substitute the values. So we get distance PQ is equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Now in the next step you are supposed to actually substitute the values. So here, for the sake of simplicity or for our understanding, we have already decided which coordinates are x1 y1 and which coordinates are x2 y2. So simply by referring to these values, we can substitute the values here in the formula. So we get PQ is equal to square root of x2 is 4 minus 2 bracket square plus y2 minus y1 is 7 minus 5 bracket square. So we get PQ is equal to, square root of 4 minus 2 is 2 square plus 7 minus 5 is also 2 square. So we get PQ is equal to square root of 4 plus 4, that is PQ is equal to square root of 8. And if you find the square root of 8 by means of the method of prime factorization, you get PQ is equal to 2 root 2 units. So distance between the points P and Q is 2 root 2 units. So here we have used the distance formula to find distance between any two given points. Okay, now with respect to this distance formula, there is a special case. So a special case of distance formula is, distance of a point from the origin. Okay, distance of a point from the origin. So if you might recall, we denote origin by the capital letter O and its coordinates are 0, 0. Okay, so if let's assume that we have to find distance of a point, let's say point A, whose coordinates are x1 and y1. Okay, from the origin whose coordinates are 0, 0. So we start with the formula, distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. So we have distance OA is equal to square root of, again write down the formula, that is x2 minus x1 whole square. It is x2 minus x1 whole square plus y2 minus y1 whole square. So here we have already assumed the coordinates of point A as x1, y1. Therefore, coordinates of point origin will be considered as x2, y2. So this becomes OA is equal to, I'll do some copy paste work. So OA will be x2 is 0 minus x1, y2 is 0 minus y1 square. So we get OA is equal to, square root of minus x1 bracket square plus minus y1 bracket square. So always remember, whether the given number is positive or negative, its square is always positive. Whether the given number is positive or negative, its square is always positive. For example, square of plus 3 is plus 9 and square of minus 3 is also plus 9. So we get OA is equal to square of minus x1 is x1 square. Square of minus x1 is x1 square. Similarly, square of minus y1 is y1 square. So we get the formula as the distance between the given point and the origin is square root of x1 square plus y1 square. Square root of x1 square plus y1 square. So this is the special case of distance formula to find the distance of a point from the origin. Okay, so this is the special case of the distance formula where we find the distance of the given point from the origin. So let us consider an example. Let us consider an example. Find the distance of point P whose coordinates are let's say minus 4, 3. Okay, whose coordinates are minus 4, 3, and from where? From the origin. So distance of a point, you must write distance of a point from the origin is calculated as square root of x1 square plus y1 square. Okay, now here you must note down what is x1 and what is y1. So we have x1 is equal to minus 4. We have x1 is equal to minus 4 and y1 is equal to 3. So substitute the value. So distance of a point from the origin. So distance of point P from the origin will be OP. OP will be equal to square root of, so square of minus 4. So it is square of minus 4 plus square of 3. x1 square plus y1 square. Okay. So we get OP is equal to square root of square of minus 4 is plus 16 plus square of 3 is plus 9. So we get OP is equal to square of 16 plus 9 is 25. So we get OP is equal to 5 units. So this is how we calculate the distance of a point from the origin.